March 1943, North Atlantic. A British destroyer closes in on a German U-boat lurking beneath the gray, churning waters. The sonar operator tracks the submarine with precision. The distance closes. 300 yards, 200, 150. Then nothing. The submarine vanishes from the screen. The destroyer commander knows what comes next. His ship must pass directly over the target, drop depth charges from the stern, and pray. By the time those charges explode at their preset depth, the U-boat will be long gone, slipping away into the darkness while the massive underwater explosions scramble every sonar reading for the next 15 minutes. This scene played out hundreds of times in the Atlantic. Convoy escorts detected submarines, closed for the attack, lost contact at the critical moment, and watched their prey escape. The U-boats were winning. Allied merchant ships went down by the hundreds, their crews lost to the icy waters. Britain was being strangled. Something had to change. What those destroyer captains didn't know was that a secret weapon was already being developed, a weapon so revolutionary that it would flip the entire underwater war on its head, a weapon that would turn hunter into hunted, that would make the mighty U-boats helpless against a shell they never saw coming. This is the story of Hedgehog, the British innovation that changed everything, and of the men who wielded it with deadly precision. Every fact you're about to hear is verified. Every number documented. This is history as it actually happened. Before we dive deeper into this incredible story, do me a favor. If you're enjoying this content, hit that like button and subscribe to the channel. It really helps us continue bringing you these untold stories from World War II. And stick around, because what you're about to discover will change how you see the Battle of the Atlantic forever. To understand why Hedgehog was so revolutionary, we need to understand the nightmare that was anti-submarine warfare in the early years of the war. When a destroyer or corvette detected a U-boat on sonar, the equipment worked beautifully at range. A skilled operator could track a submarine from thousands of yards away, guiding his ship toward the target with confidence. The problem came at close range. As the distance dropped below 300 yards, something catastrophic happened. The returning sonar echo merged with the outgoing ping. Operators called it the instantaneous echo. The submarine completely disappeared from detection at precisely the moment when accurate targeting mattered most. The U-boat commander, if he was experienced, knew about this blind spot. He would wait until the destroyer got close, then execute desperate maneuvers. A hard turn to port or starboard, a crash dive to maximum depth, a reduction in speed to minimize noise. For those critical final moments, he operated in complete acoustic darkness, invisible to his hunter. The destroyer captain had to guess where the submarine might be, then order his crew to roll depth charges off the stern. These charges, heavy barrels packed with high explosives, would sink to their preset depths and detonate. The problem was timing and positioning. By the time the destroyer passed over the submarine's last known position and released the charges, precious seconds had elapsed. The submarine had moved. When the depth charges finally exploded, they created massive underwater concussions that could devastate a submarine if they were close enough. But most of the time, they weren't close enough. And here's the real problem. Those explosions completely disrupted sonar for up to 15 minutes. The water became an acoustic mess, filled with turbulence, bubbles, and reverberating shock waves. The destroyer had to wait, drifting, while its sonar team prayed for the water to settle enough to search again. If the U-boat survived that first attack, and statistics show that most did, it had a 15-minute head start to escape. The U-boat could run silent, change course, dive deeper, or surface and flee at top speed. The odds heavily favored the submarine. In 1940 and 1941, these odds translated into staggering losses. German U-boats were sinking Allied merchant ships faster than they could be replaced. The tonnage going to the bottom of the Atlantic represented food, fuel, weapons, and supplies that Britain desperately needed to survive. Every convoy that left North America for Britain ran a gauntlet of submarines. The wolf packs, as they were called, operated with devastating efficiency. British and Canadian escorts did their best, but the tools they had simply weren't good enough. That's when a British naval officer named Commander Charles Goodeve entered the picture. Goodeve wasn't a traditional Navy man. He was a scientist, a problem solver, someone who looked at the depth-charge dilemma and saw it for what it was, a fundamental design flaw. Depth charges required you to pass over the target before attacking. They exploded whether they hit anything or not, disrupting your own sonar and giving away your position. And they forced you to guess the submarine's depth, a guess that was wrong far more often than it was right. Goodeve asked a simple question. What if we could attack forward instead of aft? What if we could fire projectiles ahead of the ship toward the submarine's position while it was still visible on sonar? What if those projectiles only exploded on contact with the target, preserving sonar contact and preventing wasted attacks? The concept was brilliant in its simplicity. The execution would prove far more difficult. The weapon that emerged from Goodeve's team was called Hedgehog, and it looked unlike anything the Navy had seen before. Imagine a frame mounted on the foredeck of a destroyer holding 24 short, stubby projectiles arranged in rows. These weren't streamlined shells. They looked crude, almost primitive, with flat noses and tubular tails. Each projectile weighed about 65 pounds and carried 30 pounds of high explosive. The launcher could fire all 24 projectiles in a single salvo, hurling them in an elliptical pattern about 200 yards ahead of the attacking ship. Here's where it got interesting. Those projectiles used contact fuses. They only exploded if they actually struck something solid, a U-boat's hull, the seabed. If they missed, they simply sank to the bottom without detonating. This meant that when a Hedgehog salvo hit the water, sonar operators could continue tracking the submarine. No massive explosions to scramble the sensors, no acoustic blindness. If the projectiles missed, the destroyer could immediately fire again, adjusting aim based on real-time sonar data. And if they hit, well, the submarine's crew would know about it immediately. The flat-nose design was critical. Engineers had discovered through testing that conventional pointed projectiles tended to skip off the water's surface at shallow angles, destroying their accuracy. The flat nose prevented skipping, ensured stable flight, and maximized the transfer of explosive force upon impact. The tubular tail provided stability during flight and descent through the water. Every detail had been calculated and tested. Initial tests began in 1941. Engineers constructed submarine hull sections and positioned them at various depths and angles. They fired Hedgehog salvos and measured the results. The early projectiles carried only 20 pounds of explosive, but tests revealed this wasn't enough to guarantee a hull breach. The charge was increased to 30 pounds, then to 35. They studied the distance between a U-boat's outer deck and its inner pressure hull. This distance determined whether a hit on the outer deck would still transfer enough explosive force to breach the inner pressure hull. Every variable was measured, calculated, and optimized. By late 1942, Hedgehog was ready for operational deployment. The first systems went to British destroyers and corvettes in the North Atlantic. Crews trained on the new weapon with mixed enthusiasm. Some captains loved the concept. Others remained skeptical, wedded to their depth charges and traditional tactics. The real test would come in combat against experienced U-boat commanders who had survived years of warfare. The weapon's first successes came in early 1943. British escorts using Hedgehog began scoring kills against U-boats that had previously escaped. The statistics started to shift. Submarines that once slipped away after depth charge attacks now found themselves under a new kind of assault. No warning, No approaching thunder of propellers overhead, just sudden, catastrophic detonations against their hull as contact-fused projectiles found their mark. From the U-boat's perspective, Hedgehog attacks were terrifying. A submarine commander tracking an approaching destroyer on his hydrophones would expect the familiar pattern. The destroyer would pass overhead, depth charges would drop, and he would execute evasive maneuvers during the blind period that followed. But with Hedgehog, there was no overhead passage. The projectiles came from ahead, splashing into the water while the destroyer was still at distance. The U-boat commander might hear the splashes, might even order evasive action, but he had no way to know where the projectiles would land. And if they struck, there was no armor that could save him. Let me paint a picture of what happened when a Hedgehog projectile struck a U-boat's pressure hull. These submarines were marvels of engineering, designed to withstand the crushing pressure of deep water. A Type Anwavite U-boat, the most common German submarine, had a pressure hull made of steel approximately half an inch thick. This hull could theoretically survive depths of up to 250 meters before catastrophic failure. But that protection was designed for external water pressure, not for explosive impact. When a Hedgehog projectile struck the hull, the contact fuse triggered instantly. 35 pounds of high explosive detonated against the steel, creating a localized pressure wave of incredible intensity. The explosion punched a hole through the pressure hull, typically between 6 and 12 inches in diameter. At depth, this hole became a high-velocity water jet. Remember, at just 100 feet depth, water pressure is about 43 pounds per square inch. At 200 feet, it's double that. This water didn't leak through the hole. It blasted through at tremendous velocity, flooding the submarine's interior compartments in seconds. The U-boat's buoyancy tanks flooded immediately. Depth control became impossible. The submarine began to sink, gaining speed as it descended beyond its operational limits. The crew, if they survived the initial explosion, faced a nightmare scenario. Alarms, screaming, water flooding through ruptured compartments, the boat angling downward at an increasingly steep angle. They could attempt damage control, but a Hedgehog breach was typically catastrophic. As the boat sank deeper, external pressure increased exponentially. At approximately 350 meters, well beyond the Type SEM's design limits, the hull would fail completely, not gradually, catastrophically. The implosion was violent and sudden. The remaining air inside the hull compressed into a superheated plasma lasting only milliseconds. Internal temperatures spiked to hundreds of degrees. The crew's lungs would sear. Consciousness would fade, not from drowning, but from breathing superheated steam. Then the hull collapsed inward with such force that it generated a shock wave powerful enough to register on sonar miles away. Allied sonar operators called it breaking up noises, a heavy, crunching explosion that propagated through the ocean like underwater thunder. And then silence. The U-boat and its crew ceased to exist. This wasn't a quick process. From initial hit to final implosion could take 2 to 3 minutes, long enough for the crew to understand what was happening, long enough to realize there was no escape. German U-boat crews had always known their service was dangerous. They called their boats iron coffins, but Hedgehog made the coffins smaller, made escape even less likely. As 1943 progressed, more Allied escorts received Hedgehog systems. The weapons spread from British ships to Canadian vessels and eventually to the United States Navy. American destroyer escorts began mounting Hedgehog on their foredecks, training crews in its use and putting it to work in both the Atlantic and Pacific theaters. And that's where our story takes a remarkable turn, to the Pacific, to a destroyer escort called USS England, and to a record that has never been broken. May 1944, the Pacific Theater. American forces are pushing toward the Philippines, and Japanese naval commanders are desperate to gather intelligence on the advancing fleet. Admiral Soemu Toyota, commander of Japan's combined fleet, orders a screen of submarines to establish a picket line east of the Admiralty Islands. These submarines are supposed to detect American ship movements and radio back critical information. They're operating in a coordinated pattern, maintaining radio communication with headquarters. That communication is about to become their downfall. American codebreakers intercept and decode Japanese submarine traffic. They know where the picket line is positioned. They know the approximate locations of individual submarines. 3 American destroyer escorts receive orders to hunt down and eliminate this threat. The Ruby, the George, and the England. All 3 ships carry Hedgehog systems. All 3 have trained extensively in anti-submarine warfare. But the England has something extra. Her executive officer, Lieutenant John Williamson, has turned the ship into what the crew calls a taut ship, meaning everything runs with precision. For months, Williamson has drilled the sonar operators, Hedgehog crews, and engine room gang until they function like a precision machine. The sonar operators can identify submarine contacts from minimal returns. The Hedgehog crews can reload in 30 seconds. The engine room can execute speed changes instantly, putting the ship exactly where it needs to be for optimal firing position. This level of training is about to pay devastating dividends. May 19, 1944. The England sonar team picks up a contact. Submarine range approximately 1,500 yards. The contact is classified as a Japanese I-class submarine, I-16, one of the largest submarines in the Japanese fleet. The England's captain, Commander Walton Pendleton, orders an attack approach. The ship turns toward the contact, building speed. Sonar continues tracking. The submarine appears unaware it's been detected. At optimal range, approximately 250 yards, the Hedgehog crew fires a full salvo. 24 projectiles arc through the air and splash into the water ahead of the submarine's position. The sonar operator maintains contact, watching his screen intently. Then detonations. Multiple hits. The submarine's hull has been breached. Breaking up noises follow immediately, the characteristic sound of a pressure hull failing under depth. The England's crew watches as debris begins surfacing: oil, wood fragments, personal items. I-16 is gone, along with all 68 crew members. But Admiral Toyota still has submarines in position, and American codebreakers are still reading Japanese traffic. May 22nd. The England receives new coordinates. Another submarine, RO-106, is operating nearby. The hunt continues. This time the contact comes at dawn. The England sonar picks up the submarine at range, tracks it patiently, and closes for attack. 1 Hedgehog salvo, multiple detonations. RO-106 destroyed, 56 crew lost. May 23rd. A 3rd submarine, RO-108. The 3 destroyer escorts are supposed to be heading for resupply. The Hedgehog magazine on the England is half empty. The crew has been on continuous alert for 7 days. But this is a clear contact, and the submarine hasn't detected them yet. Pendleton orders 1 attack run. RO-108 dives when it detects the destroyer's engines. Too late. Williamson has a solid sonar lock, 1 Hedgehog salvo, 4 to 6 hits. Breaking up noises follow immediately. 53 Japanese sailors perish in less than a minute. The England isn't finished. May 24th, RO-105. Another contact, another attack, another successful kill. The Japan submarine never had a chance. May 26, RO-108. Wait, I apologize, that's RO-116. 5th submarine in 8 days. And perhaps most importantly, crew training that turned the weapon system into a precision instrument. The Japanese Navy was baffled. Submarines were disappearing without warning, without survivors, without any clear understanding of what was happening. RO-117, another submarine in the picket line, was eventually located and destroyed by other American forces before the England could make its 6 kills. Admiral Toyota's entire early warning network had been systematically eliminated. But the Pacific wasn't the only theater where Hedgehog proved its worth. Back in the Atlantic, the weapon continued its deadly work against German U-boats. Let me tell you about another engagement, this one involving USS Elmore and U-549 in May 1944. The Elmore was escorting a convoy when sonar detected a submarine contact. U-549, a Type Wang-C U-boat, was stalking the merchant ships, positioning for a torpedo attack. The Elmore turned toward the threat, building to attack speed. The U-boat's commander realized he'd been detected and attempted evasive maneuvers. Too late. The Elmore's Hedgehog crew launched their first salvo. No hits. The submarine jinked hard to starboard, trying to throw off the attack. The Elmore's engines purred smoothly as they repositioned. 30 seconds to reload. Second attack. 3 detonations. Direct hits on the pressure hull at approximately 250 feet depth. 4 minutes later, sonar operators heard breaking up noises. When 3 Hedgehog projectiles punched holes in U-549's pressure hull, seawater drove through those openings at catastrophic velocity. The submarine's buoyancy tanks flooded immediately. Depth control became impossible. As the boat sank deeper, external pressure increased exponentially. At approximately 350 meters, the hull failed catastrophically. The implosion generated a shock wave powerful enough to register on sonar miles away. U-549 and her crew were gone. These engagements, and hundreds like them, changed the course of the Battle of the Atlantic. In 1942, before Hedgehog entered widespread service, U-boats were sinking Allied merchant ships at an unsustainable rate. By mid-1943, the tide had turned. The reasons were multiple: improved radar, more escort ships, better convoy tactics, long-range air cover closing the mid-Atlantic gap. But Hedgehog played a critical role. When escorts made contact with a U-boat, they could now press home attacks with a much higher probability of success. The statistics tell the story. Traditional depth charge attacks resulted in a target being destroyed approximately 5% of the time. Hedgehog attacks, when they scored hits, destroyed the target over 90% of the time. Of course, Hedgehog salvos missed more often than they hit. But when they connected, the result was almost always fatal. And unlike depth charges, a miss didn't end the attack. The escort could fire again immediately, adjusting based on sonar feedback. German U-boat commanders began reporting encounters with a new British weapon. They described projectiles that landed ahead of the attacking ship, that detonated only on contact, that gave no warning. Some commanders who survived Hedgehog attacks spoke of near misses, of projectiles splashing into the water around their submarines, of the terror of not knowing when or where the next salvo would land. The psychological impact was significant. U-boat crews already faced incredible stress. The addition of a weapon that struck without warning, that could find them even when they thought they were safe, added another layer of fear. By 1944, Hedgehog had become standard equipment on Allied escort vessels. Production ramped up to meet demand. Variations on the basic design appeared, including a larger launcher called Squid that fired 3 larger projectiles with more explosive power. But Hedgehog remained the workhorse, reliable and effective. The weapon wasn't perfect. It required skilled sonar operators to provide accurate targeting data. It needed well-trained crews to load and fire the salvos correctly, and it was less effective in rough seas, where the elliptical pattern of projectiles could spread too widely to guarantee hits. But in the hands of competent crews, under reasonable conditions, Hedgehog transformed anti-submarine warfare. Think about the broader implications. Every U-boat destroyed meant fewer merchant ships lost. Every submarine that failed to return to port represented months of construction time, trained crew lost, and resources diverted. Germany's U-boat fleet was formidable, but it wasn't infinite. As losses mounted through 1943 and 1944, the Kriegsmarine struggled to replace both boats and experienced crews. New U-boat commanders went to sea with less training, less experience, and faced increasingly sophisticated Allied defenses. The combination of Hedgehog, improved radar, high-frequency direction finding, code-breaking, and escort carriers created a defensive network that the U-boats simply couldn't penetrate consistently. The wolf packs that had terrorized convoys in 1942 were broken up, scattered, hunted down one by one. By 1945, U-boat operations had become suicide missions. Crews knew the odds of survival were minimal. Many boats were destroyed on their first patrol. The weapon that Admiral Karl Dönitz had counted on to strangle Britain had been neutralized. And at the heart of this transformation was a simple innovation, a forward-throwing weapon with contact fuses, 24 stubby projectiles that could be fired while maintaining sonar contact. A system that told you immediately whether you'd hit or missed, that didn't scramble your sensors, that gave you multiple chances to get it right. Hedgehog wasn't the only factor in winning the Battle of the Atlantic, but it was a crucial one. Commander Goodeve's insight that attacking forward was better than attacking aft seems obvious in hindsight. But in 1940, it represented a fundamental rethinking of anti-submarine tactics. The British Admiralty could have rejected the idea as too radical, too difficult to implement. Instead, they greenlit development, supported testing, and pushed the weapon into production as quickly as possible. That decision saved countless lives. Consider the merchant sailors who crossed the Atlantic in convoy. In 1942, they watched ships around them explode and sink, knowing their turn might come at any moment. By 1944, those convoys were much safer. U-boat attacks decreased dramatically. The escorts around them carried weapons that actually worked, that could find and destroy submarines before those submarines could launch torpedoes. The difference was measurable in lives saved and cargo delivered. Consider also the escort crews. Destroyer and corvette sailors spent months at sea in brutal conditions, hunting an enemy they could rarely see. Before Hedgehog, attacking a submarine was an exercise in frustration. Make contact, close in, lose contact, drop depth charges, wait, and hope. More often than not, the submarine escaped. With Hedgehog, those same crews could press home attacks with confidence. They could see the results on their sonar screens. They knew when they'd scored hits. They knew their weapon could actually finish the job. The USS England's crew certainly knew. After their incredible 12-day spree, they became celebrities. 5 submarines destroyed in that short period represented a feat of anti-submarine warfare that stunned even experienced naval officers. Admiral Ernest King, Chief of Naval Operations, sent a message to the England. There'll always be an England in the United States Navy. The crew received commendations. Their tactics were studied and disseminated to other destroyer escort crews. Lieutenant Williamson's training methods became a model for the fleet. But for all the success stories, it's important to remember the human cost on both sides. Every U-boat destroyed represented dozens of sailors entombed in their steel coffin, sinking into the darkness. These were young men, following orders, fighting for their country as they understood it. The Hedgehog attacks gave them no chance of survival. When the pressure hull breached, when the boat began its final dive, there was no escape. U-boats didn't carry enough escape equipment for the entire crew, and at the depths where catastrophic hull failure occurred, escape was physically impossible anyway. German U-boat crews had one of the highest casualty rates of any service in World War II. Approximately 75% of U-boat sailors who served did not survive the war. They knew the odds. They went to sea anyway, motivated by duty, by propaganda, by the bonds of crew and service. Hedgehog made those already terrible odds even worse. On the Allied side, every successful Hedgehog attack meant a convoy that survived, a destroyer that didn't take a torpedo, merchant sailors who made it home. The weapon helped turn the tide in a battle that could have lost the war. If the U-boats had succeeded in cutting Britain's Atlantic lifeline, if the flow of food and supplies and weapons had been strangled, Britain might have been forced to negotiate. The entire course of the war in Europe depended on keeping those convoys running. Hedgehog helped make that possible. The technology behind Hedgehog seems simple by modern standards. Contact fuses, forward-throwing launchers, basic sonar tracking. But in 1941, this represented cutting-edge anti-submarine technology. The engineering challenges were significant. The projectiles had to be rugged enough to withstand launch forces, stable enough to fly accurately, heavy enough to sink quickly, and sensitive enough to detonate on contact with a submarine hull without detonating on contact with the water's surface. The launch mechanism had to fire all 24 projectiles in a precise pattern, accounting for ship motion, wind, and target distance. Testing revealed problems that had to be solved. Early projectile designs were unstable in flight. The fusing mechanism sometimes failed to detonate on impact. The launch frame needed reinforcement to handle repeated firings. Engineers worked through each issue methodically, testing solutions, refining designs, and eventually producing a weapon system that was both reliable and effective. Production was another challenge. Britain's war industries were already stretched thin, producing aircraft, tanks, ships, guns, and ammunition. Adding Hedgehog production required allocating resources, training workers, and establishing quality control procedures. The United States, with its massive industrial capacity, took over much of the production as the war progressed, supplying both American ships and Allied vessels through Lend-Lease. By war's end, hundreds of ships carried Hedgehog systems. The weapon had proven itself in the Atlantic, the Arctic, the Mediterranean, and the Pacific. It had destroyed dozens of submarines and contributed to the destruction of dozens more in coordinated attacks. The design influenced post-war anti-submarine weapons, with the principle of forward-throwing contact-fused projectiles becoming standard. If you've made it this far in the story, I want to thank you for watching. This is the kind of detailed, researched history that takes time to create. If you enjoyed it, please hit that subscribe button and leave a comment below. What other World War II naval stories would you like to hear about? Your feedback helps shape future content. The legacy of Hedgehog extends beyond World War II. Modern anti-submarine warfare still uses forward-throwing weapons, though they're far more sophisticated than Hedgehog. Missiles, torpedoes, and advanced depth charges can be launched ahead of the attacking ship, guided to target, and detonated with precision. But the fundamental principle that Commander Goodeve established, that forward attack with maintained sonar contact is superior to aft attack with lost contact, that principle remains valid. In the decades after the war, veterans from both sides of the Battle of the Atlantic shared their stories. German U-boat survivors spoke of the terror of depth charge attacks and the even greater terror of Hedgehog attacks that gave no warning. Allied escort veterans remembered the frustration of early war anti-submarine operations and the satisfaction of finally having a weapon that worked. These oral histories, preserved in archives and museums, give us insight into the human experience of technological warfare. The Battle of the Atlantic was, in many ways, a battle of innovation. Each side developed new weapons, new tactics, new technologies. The Germans introduced acoustic torpedoes, snorkel systems to run diesel engines while submerged, and improved submarine designs. The Allies countered with radar, sonar improvements, escort carriers, long-range patrol aircraft, and weapons like Hedgehog. It was an arms race played out across thousands of miles of ocean, with the stakes being Britain's survival. Hedgehog represented one chapter in that larger story, but it was a crucial chapter. The weapon arrived at a critical moment, when the U-boat threat was at its peak, when Allied shipping losses threatened to become unsustainable. It provided escort commanders with a tool that could actually kill submarines, that could turn detection into destruction. Combined with other improvements, it helped shift the balance from German advantage to Allied advantage. The men who designed Hedgehog, who tested it, who manufactured it, and who wielded it in combat, probably never imagined how important their contribution would be. Commander Goodeve wasn't trying to change the course of the war. He was trying to solve a tactical problem, to give escort ships a better weapon. The engineers who designed the projectiles were focused on fusing mechanisms and ballistics, not grand strategy. The factory workers producing Hedgehog systems were doing their jobs, contributing to the war effort. And the sailors firing those salvos were trying to protect their convoys and sink enemy submarines. But collectively, all of these contributions added up to something significant. A weapon system that worked, that saved lives, that helped win a battle that could have lost a war. That's the power of innovation in warfare. Small improvements, tactical advantages, can cascade into strategic victories. The story of Hedgehog is also a story about the importance of being willing to challenge conventional thinking. The traditional depth charge doctrine was well established in 1940. Naval officers had trained with depth charges for years. Tactics were standardized. Equipment was produced. Changing all of that to accommodate a new weapon system required institutional flexibility. The British Admiralty, to its credit, recognized Hedgehog's potential and pushed it through development and deployment quickly. Not every military institution in history has been that adaptive. As we reflect on this history, it's worth considering what lessons might apply today. The importance of forward-thinking innovation, the value of questioning established methods, the need to equip forces with tools that actually work, not just tools that are traditional. The Battle of the Atlantic was won through a combination of courage, sacrifice, and superior technology. Hedgehog was one piece of that technological puzzle. In the end, the secret shell that made U-boats helpless was no longer secret by war's end. German intelligence had figured out what the Allies were using, but by then it didn't matter. The damage was done. The U-boat fleet had been decimated. The Battle of the Atlantic was won, and a simple forward-throwing weapon with contact fuses had played its part in that victory. The submarines that Hedgehog destroyed, along with their crews, now rest on the ocean floor, some in the Atlantic, some in the Pacific, some in other waters where the war was fought. They're war graves, protected by international law, silent reminders of the men who fought and died in the undersea war. The destroyers and escorts that carried Hedgehog, most of them were scrapped after the war, their useful lives ended, their steel recycled. A few survive as museum ships, preserved so future generations can see what these vessels looked like, how they were equipped, what conditions their crews endured. But the story of Hedgehog lives on in the historical record, in the official reports that documented each attack, in the sonar logs that tracked submarines to their destruction, in the survivor accounts from both sides. It's a story of innovation, of technological warfare, of the men who fought the Battle of the Atlantic. It's a reminder that wars are won not just through courage and sacrifice, but through superior weapons, better tactics, and the willingness to adapt and innovate. The U-boats never saw it coming, those stubby projectiles splashing into the water ahead of the attacking ship, those contact fuses that only exploded on impact, those hull breaches that sent submarines to the bottom with no chance of survival. The German submarine service, which had terrorized Allied shipping for years, found itself hunted by a weapon it couldn't counter. The hunters became the hunted. The predators became prey. And the secret shell called Hedgehog changed the course of the war. The England executes a perfect Hedgehog attack, multiple hits, catastrophic hull breach. The submarine sinks with all hands. 5 submarines destroyed in 12 days. This record has never been broken in submarine warfare history. The England success demonstrated everything that made Hedgehog so effective. Forward-throwing attack that maintained sonar contact throughout. Contact detonation that only registered hits, not misses. Rapid reload capability that allowed multiple attacks.